moving on. Somebody asked the question, again, let me hide that. Somebody asked the question, what if we had multiple classes? See, the strategy in this class is to be on the lookout for that tenth of a second when the slide shows up, and use your iconic memory, and then you have all the answers you need, right? So, how might we handle everything that we saw so far is for learning with one class? What if I have half a dozen? What should I do there? Any suggestions? Let's, remember, in machine learning, we're lazy and we're stupid, so we like to do something simple and easy, right? So, what is the simple, easy thing to do here?
Each class one at a time?
Precisely, right? Always try to use what you already have as a black box, right? This is a golden rule in all of computer science, right? Let's say I already have a black box for learning, one class, right? How do I bootstrap that black box into an algorithm for learning multiple classes? Well, just learn rules for each class in turn against all the others, right? No change. Very good. So I've just done that. Are we done? So I have classes A, B, C, and D. I have a bunch of rules that says if this rule fires your A, if this rule fires your B, and so on. Are we done? Or do we need something else?
I think those rules could overlap, right?
Yep.
You have to solve that problem.
Exactly. So if the rules overlap, what do, right? A rule for class A fires, and the rule for class B fires. So what do I do now?
Can you build rules that apply when two or more rules happen to coincide?
I can contrive the rules such that they're mutually exclusive. Isn't that a devious idea? And what do you get in that case? You get a decision tree. Historically, actually, rules precede decision trees. But you can, but then there was this problem. I'm abusing history a little bit here, but this is not entirely, incorrect. When you learn decision tree rules, which at least for people coming from an AI background were very natural because, expert systems and all that stuff, that's what they use with sets of rules. But there was always this very thorny problem of how do you combine the rules. If you contrive the rules to have mutually exclusive antecedents, you never have that problem. And that makes decision trees kind of attractive in some ways. But, like today, our agenda is, we're going to do this with rules. So what might you do?
Sort them by confidence?
Precisely, right? We already looked at this last time. We can sort them by confidence or by some measure of quality, and the first rule wins, right? So we order them into what is called a decision list, which is really a kind of case statement, right? Natural idea. But we also saw that, and this is a often used method. We also saw last time that this is typically not the best method in terms of accuracy. What is the best method? Voting, right? Democracy. We like democracy, right? The rules all get to vote. Right? Because suppose that the most accurate rules said class A, but then there's 10 slightly less accurate rules all saying class B. Would you be really stubborn in that case and still favor class A? No. At that point, maybe the balance of evidence favors class B. Right? I have one rule firing saying this is a chair, and I have 10 rules saying it's a table. Well, I might go with the table. Okay? So what you do is you vote. You have a set of rules. Each one has some sort of coefficient, like, coverage, accuracy, and whatnot, and then they vote according to these coefficients, and whichever class gets the most weighted votes wins. There's other ways to combine them, some of them quite, interesting, probabilistically. We will look at some of these ideas later, but, this actually works pretty well and is easy to implement. Okay? It has the disadvantage that it's the slowest, right? Because I need to run through all the rules, see if they all match, and then vote them, as opposed to as soon as one of them fires. And remember, typically the rules at the top cover a lot of examples, so there's a good chance that one of the early rules will fire. So this is the slowest method, but in terms of accuracy, it tends to be the best one. Okay? Questions?
So this problem doesn't really exist in decision trees, right? Decision trees are completely, you could have any number of classes.
Decision trees are immune to this problem because I always go into exactly one leaf, and that leaf predicts exactly one class. So that's one advantage of decision trees. One of the things that you should be able to do when you're done with this class is when faced with a new problem, right? When faced with an application for machine learning, think about these various algorithms and representations and see what is good for this problem versus what is not. Right? Which is why it's important for you to see a good sample of these things. And of course, it's not a random sample; it's the most widely used ones, and it's a varied set. But you want to have that understanding of what the options are and the strengths and the weaknesses and so forth. Okay. All right. Somebody had a question?
What do you do if none of the rules apply?
Oh, absolutely. Great question. Darn, I forgot that. What do you do when none of the rules apply?
coin?
It's a negative case.
You do what?
It's a negative example.
But what is a negative example if I have multiple classes and I learn the rule for each of the classes, right? There are no negative examples anymore.
You're missing your class.
Well, couldn't you just define sort of a default class?
Yeah, precisely. You can have a default prediction, right? What is the single most frequent class overall? What is the single most frequent class among examples that none of the rules cover? Right, remember, in reality, we're going to prune, right? So the rules aren't going to cover all the examples, so I could see what is the most frequent remaining class, and then I predict that. Or you could just tell the user, hey, I don't know. Some machine learning systems have what's called a reject option, which is, I'm not confident. This is actually what the post office uses or used to use for things like, figuring out the zip code on letters. If the character recognition system was confident that it knew the zip code, it would get sorted automatically. Otherwise, there's a reject option that says, like, a human had better look at this. Okay? So you also have that option. By the way, even for the case where I only have two classes, the best performing method is to learn rules for one class and for the other class, and then vote them or order them. It's typically more robust. So in the case of two classes, I don't have to do that. I could just learn rules for one class. But I'm usually better off actually having rules for both of them and then having some ordering procedure or some voting procedure. Okay? Any questions? Very good.